Okay, so in this video, I will tell you this question, symmetric tree. It is an easy level question and it has been asked in a lot of companies. Yes. So given the root of binary tree and check whether it is a mirror of itself or not. So we have to check, is this a binary tree's mirror of itself or not? So when I'm saying mirror, here mirror means its root will be mirror. Why? Because see, its one root is this and its second root is this. Both roots are mirror of themselves. See this. This is 2. This is also 2. Yes, it's see, if you see this, suppose this is a mirror. Yes, this is a mirror, suppose. So this 4 and here its right is 4. Yes, and its left is 4. Yes, and its left is 3, its right is 3. That's and first root will always be mirror of itself. Yes, so this is our code. So this is our question. So how can we do this? So I will do this question recursively. How can we do this recursively? I will create a function. See, I will not create a function. Function is created here itself. So I will do what? I will suppose I will create a function like its function name is mirror. Yes, and I will pass two things inside it. Yes, to what are those two things? I will first pass this. I will first pass this two means root dot left. I will first pass this root dot left, and then I will pass root dot right to it. Yes, so inside it I will pass 2 comma 2. Wait. I'll pass 2 comma 2. Yes, inside this function. So let me log this image. Yes, and now I'm clearing this whatever I wrote. So I will create this function. I'll call it here. Yes, I'll call at first node this function at this. This function will be called at 2 comma 2. Yes. Now what will this function do? Inside it, this function will call the same function again with what? With, see, I'm calling this function with 2 comma 2. Now this function will call itself again with, this function will call itself again with this 3 comma 3. Why 3 comma 3? This function will call this same function with, suppose this is p, so p dot left and q dot right. Yes, this is q. Yes, this is q and this is p. So it will call it with p dot left and q dot right. Yes, so p dot left is what? P dot left is let me write this. P dot left is 3 and q dot right is also 3. So this function will call it like this. Now again both the nodes are equal. See, this is 3 and this is also 3. So yes, this is a valid function. Okay, now this same function and this will call another function. This same function will call another function. First it will call this function, then it will call another function which is what? Just see this, is with p dot right. This is p, its right is what? Its right is 4 and q dot left. Okay, p dot right and q dot left. So if I write like this, p dot right is 4 and q dot left is also 4. This will call. So now see, both the nodes are equal. Yes, then we call this function with 4 comma 4. Now inside this 3 comma 3 will call the same function with 3 comma 3. Now see, let me undo it and I'm changing color. This 3 comma 3, see, execution of this function is done. This function has called two function and now its work is done. Now these two function will call another two function. What are those function? First this will call the same function with 3 dot right, 3 dot left and this 3 dot right, p dot left and q dot right. It will call. So both are null. Yes, both are null. So we will just return true from this. Yes. Now the same function will call this is mirror function. This, see, that is mirror 2 comma 2 called two function. First is this and second is this. Both the arrows, pink arrows. Yes. Now this green function will also call two function. First it will call with p dot right, left and this q dot right. P dot left and q dot right. Now it will call with p dot right and q dot left. Yes. I'm changing again color. So now it will call it with p dot right and q dot left with these two nodes, and they are also null and null. So again, this will also give us true. Yes, this will also give us true. So if true, then we will return true from this function. Yes. And now this is mirror will also call these two function with again like this and like this. Yes, and this will also give us true. So see, whenever we will get any false means our answer is false, otherwise we will get true at every step. So I will give and I will take and of these two. Okay, then this true will go here, and this is our answer, true. Yes, so I am writing code for it. I have explained it to you. Now I am writing, and see, this recursive code is very interesting. Whole recursion is very interesting. That's why I love this topic. So let not temp. So what can I do here? I'm creating a function. Function. I told you I will do that only. What I told you. Mirror. Okay. So I'll call a is mirror function here, and in that is mirror function, I will call it with root dot left comma. Uh, see, not like this. P comma q. Let's write p comma q. Yes, and this is our function. When I'll call this function, I'll call it like this: is mirror with root dot left comma root dot right. Yes, that is the way to call this function. So see, we called it with 2 comma 2. Now what will happen? This 2 comma 2 will check some conditions, some condition. I'm writing those conditions. If p is also null or q is null, q is null, then return true. Yes, return true. Yes, and if one of them is null and one of is not, suppose this node is null and this node is connected to something, one another node of 3 is connected to something and one node of 3 is null, so means our tree is unequal, and if it is unequal it cannot be symmetric anyway. So if p is null or q is null, see, and function check if both are null. This or function check if both are not null means one is null and one is another null. It can be. So that's why this or function will check that if q is null. Suppose if one of them is null, just return false. Our tree is unsymmetric. Yes, it is not symmetric. So FALSE, yes, right. So yes, and suppose if the both trees in weight they are equal, but their value is not equal. This is 2 and this is 3. Its value is 2 and its value is 3. So again, our condition is not wrong, and p dot val is not equal to q dot val. Yes, perfect. So return false. False again. So see, these are our three conditions. First time this condition will be false. Both have value 2 comma 2. Yes, so this condition will run. So this condition will not run. This will also not run, and both value are equal, so it will also not give us false. Now let left is equals to what is, I'm calling it for left, uh, p dot right. Yes, left. Sometimes I get confused in this left right play. So q dot right. Yes, okay, q dot right. Yes, again. So very good. So q dot right and left right is equals to is mirror. Yes, is mirror p dot right and q dot left. Yes, p dot right and comma q dot left. Perfect. That's our code. So this is our code, p dot right and q dot left. So these are left right. And see, when I will call for this null and null, this will return us true. That true will suppose in this function we are calling this p dot left is also null, this q dot left is also null. So it will they both will be called with null. And if they are calling, if we call this left function with null comma null, so it will return us true. Yes, suppose this function is also returning us true, then that true will go here, and I'll return left and right. Yes, so this is our code. So it will, again, this will also be true. If both are true, this will also be true. This will be returned to this function true. Why? Because we were see, inside a function we are calling a function. This function was first called with 2 comma 2. Yes, 2 comma 2, and not 2 comma 3, 3 comma 3. So that 3 comma 3 is getting true, right? We are calling a function inside function. Try run it, you will understand. That's very easy. So I'm returning left comma right, so this will return me everything. So I just now have to return this. Return. Yes. Return this function. Output of this function, and this will run. I know that this should run, but I cannot. Yes, see. If I submit this, this will be submitted. Very easy code. So that's the power of recursion. See, let me see. Is there any wrong answer? Sometimes it happens. It happens. Okay, so it's not an. It's time complexity again. O of n. Very easy and simple. So yes, O of n. So see, sometimes recursion is very good. Why? Because see, your tree is branching like this. It is branching. Its branching are increasing. It's like a virus, which is keep increasing into, splitting into two, like a nuclear reaction. Yes. So one two is divided in three and four. That three is divided in four and five, and then four and five are divided in six and six. And this recursion is also dividing in branches, and it is checking that, and very fast and very efficient code. So and see, there are hardly 5 to 6 lines. Yes, this whole code, if I write if I do the iteration code here, that will take 10 lines. Yes, we have to create a queue or stack, whatever. See, let me see, it is dfs or bfs. So we have to check like this, 2 and 2. Okay, okay, so this question can be done with you by using queue, bfs approach. Yes, I'll check this 2 comma 2 by using a queue. I can, that's very easy code again, just like this code, it's very easy. But that code will take 7 8 10 lines. Yes, this question is 6 line only, this code is 6 line only. Yes, this is a very easy code. But understanding this code is very tough. It's really tough. So that's why I say this question is tough in that case. Otherwise, it's a easy question. So thank you so much. That was my code, and if you like it, then it's okay. Thank you so much.